So our next speaker is Kelly Tseng. Kelly made a significant career shift from marketing to marine conservation after learning scuba diving. She's dedicated herself to raising awareness and fostering behavioral changes towards sustainability, working on various projects like cetacean stranding responses, sustainable fisheries, and citizen science. Her most recent experience with Reef Check in Taiwan has inspired her to further study the scientific and socioeconomic factors necessary to tackle environmental problems on a global scale. While Kelly was here, she really soaked up all the opportunities she could, everything from getting certified as a science diver to working with the 100 Island Challenge folks and learning how to see changes in coral reefs and to trace those changes, and even creating a biodiversity database of species right here in San Diego. So Kelly really soaked it up while she was here and took all of those experiences and put them into her capstone project, the title of which is Dive Through the Screen, Revealing the Past and Future of Southern Taiwan's Coral Reefs with Large Area Imaging Technology. Welcome, Kelly.
In 2020, there was the biggest coral bleaching event ever happened in Taiwan. I took this picture of a large corals that have severely bleached and posted on my social media, and the first reply I got from my friend was, "Wow, the coral is so beautiful." And that was the moment when I realized not many people from my surrounding has acknowledged what is happening under the water. As a result, most of the information that people get is from the mass media, which tend to report sensational story with negative narrative. That makes me wonder, is this a story that fits all? During my time working with Reef Check in Taiwan, I had the privilege to visiting most of the coral reefs in the country. I found so many different stories of coral reefs, even within this small island nation when facing the same threats of climate change. If we keep focusing on those single stories, would it miss the chance to identify the key process that is affecting a local reef and miss the chance to find out the appropriate management strategy that is effective to a certain region? And how can I show this information to the people who doesn't go into the water, but their life depends on ocean? That is when I found out the 100 Island Challenge. It is the initiative from Tseng and Smith Lab that using the 3D model to study coral reefs in different islands. The technology that they are using is large area imagery. It is structured from motion photogrammetry, where they use tons of images and transfer them into 2D and 3D models. It has been used extensively to study coral reefs through different time frames. This technology not only allows researchers to track changes in different coral reefs at high-resolution large area imagery, it can also serve as a powerful communication tool with the visualization. And luckily, the 100 Island Challenge has been to Taiwan to collect the data in 2018 and 2022. And it has happened to be 2 years before and after the mass bleaching event. Therefore, I become interested to using this technology to learn, did the coral reef really degrade as it was predicted? And how has the coral reef recovered since then? So now I'm going to take you all to a little travel across the ocean to Taiwan. Taiwan is an island country located on the West Pacific Ocean, and the area that I'm going to look at is the south tip of Taiwan, Kenting. Kenting is one of the places that has the most marine biodiversity in the country. 40 years ago, the government has established the first national park that has included marine area. Known for its tropical charm and convenient transportation, it has now become one of the most popular tourist destinations. However, what comes with it is the development of the coastal land, including the construction of restaurants and hotels, which resulted in sediment runoff into the ocean. And also the wastewater discharge has caused algal bloom in multiple areas. Moreover, due to the climate change, increasingly frequent typhoons and abnormal rises in sea temperature have further endangered the coral reefs. As a result, the coral reefs in this region have faced numerous impacts and threats, causing fluctuation in the coral cover over the years. The corals in Kenting demonstrate remarkable resilience in their unique environment. However, they're still facing increasingly frequent threats. The 4 study sets I chose are in 2 different geography regions, and also have different levels of marine protected area, which I will explain it later. And this allows me to get a more comprehensive understanding of the overall picture in Kenting. And in my study, I'm looking into two coral taxa. The first is Pocillopora, which is known as cauliflower coral because they look like it. And they are more sensitive to the environmental change, such as like typhoon and bleaching event. So whenever that happens, they usually experience a rapid loss. But they are also known for their fast recovery. And the second is Parietes. They tend to grow like this giant mushroom cap, and they are more tolerant to environmental change like thermal stress. These two, however, they tend to grow much slower compared to Pocillopora. And these two taxa allow me to examine how different coral reefs with different varying life history strategies has responded to the same disturbance in the region. And the method I'm going to use first is virtual point intercept. This tool will drop 2,500 points randomly on my study site, and by identifying each site to the coral genus level, I can collect the information of benthic community composition like coral cover and algae cover. And the second is TagLab. This software allows me to trace individual coral colonies throughout different time points side by side and analyze the change of their size and also the fate after the disturbance. So for the past couple months, I spent most of my life in the lab instead of the beautiful beach in San Diego. I have identified 20,000 benthic points, traced 863 colonies, and countless moments of self-doubt. This is what I found. This is a model I created for one site, 跳石. It shows the change between 2018 and 2022. And blue indicates new and growth, and the red indicates disappeared and shrinkage. As you can see in the map, that many areas are marked in red, but even more areas are marked in blue, which can be supported by my data that we found out that over half of the sites has experienced decrease in colonies numbers. However, what survived have kept growing stably. So therefore, we found out that almost every site has increased in the coral cover in these two taxa. And if we look at individual colony size change between the years, x-axis is the colony size in 2018 and one is in 2022. So the red dashed line indicates there's no change between the years. The area above shows the colonies that have grown or are new colonies, while the area below shows the colonies that have shrunk and are experiencing mortality. As you can see in the graph, the Pocillopora has experienced more completed mortality as they are more sensitive to the disturbance. However, in two taxa, even though there are a small amount of colonies has experienced shrinkage, but most of them have survived and grew into larger colonies. And this is amazing to show how much capacity of resilience of these two species in this region. And so now you might ask, well, that sounds great. Does that mean that we don't have to do anything and the coral is going to live happily ever after? Of course not. I'm going to show you more stories that we found in our data that could possibly help inform a better and more effective local management strategies. So if we look into the changes in colony size structure, we found out that Pocillopora in two sites has shown an obvious decline in small colonies. As you can see in the picture, the pink area indicates the Pocillopora colonies, and in 2018, there are some small colonies here. However, in 2022, they disappear, and there's no more new colonies in this picture. And this could result from the competition between different coral species or between algae and coral reefs. High algae cover can make it difficult for coral larvae to find suitable substrate and settle and grow. So more research is needed to determine the exact causes so we can find out the targeted intervention to solve this problem. And another interesting fact that we found is the high resilience in one of the sites, Xiangjiao Bay. This is the map that shows the colony that I traced in these sites. Blue is Parietes and pink is Pocillopora. To look at the colonies change more easily, let's take out the map and focus on the colonies. I want you to focus on the blue part, which is Parietes. This is in 2018, and this is in 2022. So the original colonies has grown bigger, and there are much more smaller colonies has settled in these sites. as we found out that Porites has increased 0.4 times more in colonies numbers, even after experienced the biggest bleaching event ever happened in Taiwan. And now I want you to look at this again at the pink colonies, which is Pocillopora. In 2018, there's not much colonies of Pocillopora in this site. However, 4 years after, there are much more growing in here, as we found out that Pocillopora has increased 3.4 times more colonies in this site. This finding might be related to the fact that Shanjiao Bay is located in the red area, which is the highest level of protected area. Of course, more research is needed to verify this assumption. However, what we can know from our data is that the environment here is beneficial to the coral reef resilience, and we should continue to maintain it. Another part of my project aims to provide information to the people who doesn't go into the water, but their life depends on the ocean. So I created this story map to show images and model videos of reef changes and tell the story of coral reef resilience in Kenting. This way, the information is no longer limited to scientific community and can reach to a broader audience. While our result may not fully represent all sites in the region, they offer a snapshot of a more dynamic and complex picture. Not every coral reef is dying. The real story is much more nuanced and complex. Coral reefs are intricate ecosystems, each with its own unique narrative and path. It is crucial to understand that one-size-fits-all conservation strategy just doesn't work. What works for one reef might completely fail for another. Each reef is a world of its own, with its own set of challenges and strengths. This kind of coral reef monitoring data can really help natural resource managers figure out what is affecting a specific reef besides just climate change. And so we can design the right and effective management plans to increase the resilience of coral reef in different areas. At the end, I want to thank my committee member, Dr. Stuart Sanding, Dr. Zhang Guo, Nathaniel Holloway. Thank you all for your guidance and your patience, and also the member in the Sanding and Smith lab, Sam, Katie, Nicole, Ami, Amy, and also Dati Pati An and Sharon Horn, and our MS and BC cohort and staff, and all the connections that I've made during this journey in Scripps.
Kelly, great talk. Your data do a really good job, I think, of showing some baseline benefits that the highest level of protection can provide. Do you think within Taiwan there might be momentum to increase the amount of marine protected areas, or is that not something that you think would be politically popular? What are your feelings about how your data might impact the policy?
I think right now, the issue of Taiwan marine protected area is that they have set a lot of marine protected area, but the problem is the enforcement. So even though my data show this result, but there's also more, because I also part of my project, I was going to interview local people to see how they feel about the enforcement, and then how they feel about, do they really know what's the management policy in that region? And because the limited time of this project, I couldn't finish that part, but I also got to interview some people and found out that actually lots of people who live there, they didn't even know that there are different levels of marine protected area. So I think that's the main problem now. So maybe this data just to show this might could the result of it, but we need more awareness or attention to this issue. Yeah.
Cool. Thank you.
Got a question. Great presentation, really, really interesting work that you've done. Is it essential to collect the data annually? And do you plan to go back to Taiwan and collect more data?
Right now, the 100 Island Challenge, because in 2018, they came to Taiwan the first time and they collected data, and then they have worked with people, the scientists in that area. And they were planning to go back in 2020, but when there was a COVID, so they couldn't go there. But in 2022, they have the collaboration with the people in National Museum of Marine Biology and Aquarium in Taiwan. So the second time point was the data was collected by the local people. And so I think that's very important for this part, because like it's very money consuming to go over there to collect the data. So it's that good that they have the partnership with local people. And then, yeah, and I have also talked with the people in the National Museum, and they were also like interested to learn what I found out in this data. And so they could like have more motivation to do more data collection in that area.
It seems from your slides like there are a lot of coral reefs in Taiwan. Are the only ones that the 100 Island Challenge have studied are the ones that you focused on, those sites, or are there others as well that they plan to focus on?
They actually collected data. In total, there are 12 sites in Kenting. And just because my limit of time, I only can do the analysis of 4 sites. So we are also very interested to find out the data of the red site, because like in Kenting area, even though that's a small area, it still have a lot like different characteristic within each site. Like there's also one site, it's very interesting that it's located at the outlet of the nuclear power station. So they tend to live in that environment, always have like a high sea temperature. And then they find out that actually the coral reefs there, they have more high tolerance of higher sea temperature. So which is also very funny. And I was planning to like look into that site, but then we found out that in the second year, something happens, they couldn't collect the data in that site. So I couldn't do the analysis of that site too. So yeah, I'm interested to find out what's the data will show in the rest of the sites.
Thank you so much.